Welcome to the Deep Dive. We're all about cutting through the noise, getting you informed, fast. Today, we're diving into Delta Lake. It's really shaking things up in how companies handle data. Our goal, show you how it turns those, sometimes messy data lakes into something reliable, high performance, basically creating this thing called a data lake house. Yeah, you know how it goes. Traditional data lakes. Super flexible, you can throw almost anything in there. But, well, that flexibility often means headaches with reliability, consistency. Then you've got data warehouses. Structured, yes. Reliable, definitely. But kind of rigid, right? Not great for all the varied data types we see today. It's a tough spot for data teams.
Absolutely. And that's exactly the problem Delta Lake tackles head on. It's this open source storage layer. Think of it as bridging that gap. You get the flexibility of the lake, but with the kind of reliability and guarantees you'd normally only find in a data warehouse.
Why does it do that, though?
It does it by adding this really robust file-based transaction log right on top of your existing storage, like S3 or ADLS. And that log, well, that's where the magic happens. It addresses some really fundamental, long-standing issues.
Okay, let's unpack that. What are these superpowers Delta Lake brings? One big worry is always data corruption, inconsistent updates in big data systems. So ACID transactions, that's a term from the database world, right? How does it apply here?
Exactly. ACID stands for atomicity, consistency, isolation, durability. It's the gold standard for reliability. Delta Lake brings that guarantee to your data lake operations. It means your changes, your transactions are always complete, correct, reliable, even with huge amounts of data.
No more half-finished jobs messing things up.
Precisely. You get that database level peace of mind, but at data lake scale. And the key, like I mentioned, is that transaction log. It's the definitive record. Every single change made to the data gets recorded there, meticulously.
Wow. Okay, so if every change is logged, what does that let me do? Can I, go back in time if I mess something up?
Yeah, you absolutely can. That detailed log enables what's called time travel, or sometimes data versioning. It's basically like having an undo button for your entire data set. Seriously powerful.
An undo button for petabytes.
Pretty much. You can query or restore your data to its exact state at any point in the past covered by the log retention. Think about it for audits, debugging pipelines, or, recovering from that accidental delete from important table moment. It saved people's bacon, believe me.
Okay, that's huge. What about data quality? The whole garbage in, garbage out thing is a constant battle. How does schema management work in Delta Lake?
Yes. Schema enforcement. It's crucial. By default, Delta Lake checks the schema of the data you're writing against the table's schema. If it doesn't match wrong data type, missing column you didn't expect, it rejects the write.
So it stops bad data getting in.
It stops unexpected bad data, yeah. It acts as a guardrail, preventing downstream processes from breaking because the data structure suddenly changed without warning. Really helps maintain data quality.
But data does change. Business needs evolve. Sources add fields. Does that strictness become a problem?
That's a really important point. And Delta Lake anticipates this with schema evolution. You can explicitly tell Delta Lake to allow certain schema changes, like adding new columns, without breaking the right operation. It lets your tables adapt gracefully over time.
Okay. So it's strict by default, but flexible when you need it to be.
Exactly. But there's a key trade-off to understand. When you enable schema evolution, you're essentially saying, okay, I'll handle potential inconsistencies myself. You bypass some of that default strictness, so it requires, careful governance. You need to know why you're evolving the schema.
Right, makes sense. Discipline is needed. Okay, shifting gears slightly. Let's talk about keeping the lake house running smoothly. What about that small file problem you hear about?
Oh yeah, the bane of many data lakes. Lots of small files happen when you have frequent updates or streaming ingest. And they kill query performance because the query engine spends ages just opening and closing files. Delta Lake has a command called optimize. It intelligently compacts those small files into fewer, larger ones.
So it just tidies things up.
Pretty much. It makes reading the data much, much faster. Running optimize periodically is standard practice for maintaining performance.
Okay, optimization for speed. What about cleaning up old stuff? Storage isn't free. All those old versions from time travel must add up.
They do, and that's where VECUM comes in. This command permanently removes data files that are no longer referenced by the transaction log and are older than a specified retention period. It's essential for managing storage costs and preventing your lake from growing infinitely.
But you need to be careful with it, right? Because it removes the history.
Exactly. You need to balance cost savings with your requirements for time travel. If you set your VACUM retention too short, say less than 7 days, you might lose the ability to roll back to older versions you potentially need. So configure it thoughtfully.
Got it. So wrapping this up, what's the big picture here for someone listening? What does Delta Lake really mean for you? Well, it seems pretty transformative. It lets you reliably handle both batch and streaming data in one place, really helps infer data quality, and generally simplifies building complex data pipelines. Plus, being open source with a big community is always a plus.
Absolutely. And to get the most out of it, think strategically. Use features like selective override, sometimes called a replace, where for targeted updates, instead of rewriting huge chunks of data, and be mindful of partitioning. Don't just partition everything. It's really only beneficial for very large tables based on how you actually query them. Delta Lake has its own optimizations that often handle things well without manual partitioning.
So, maybe a final thought to leave you with. Imagine having a system where you can instantly rewind your data, let its structure adapt safely when needed, and have guarantees about every single change. How could that fundamentally change your approach to analyzing data and making decisions?